May I please request our next panel to join us on the stage. The second panel discussion is on geospatial infrastructure for informatized warfighting, defense data infrastructure for mission reliability. May I please request A Vice Marshal Rakesh Sinha, AVSM, ACS Ops Offensive to please come on the dais. Colonel Jairam from National Security Council Secretariat. Commodore AP Gulaya from Indian Navy. Dr. Satya Chakravarti from IIT Madras. Colonel Sai Arun from Maxar. And Mr. Soyesh from Galaxy.
Good afternoon, everyone. Firstly, approaching lunchtime is becoming a real restricting factor. And coming to the, firstly, I thank the ISPA for giving us opportunity to interact here. And coming to the topic per se, that is geospatial data infrastructure. Because we have talked about persistent and resilient ISR, that is what main the defense forces look at for planning and execution. And going by the anecdote, what my friend AVM Shivanand said, because he's a air defense pilot, so he talked about air combat and perching up to maintain the situational awareness. And I'm a ground attack pilot looking after offensive operations. So we look at target systems. That is what to target, where to target, and what within the target system to target. So for the pilot, it is finally the Arjun, that is eye of the fish, that has to be hit. So that is what we are looking at. Now coming to the ISR part, we collect all the information, and like what Air Commodore Baduni covered, General Nair covered, okay, there is a huge amount of data that is available that needs to be processed. So that is where the industry has to help, because I have personally been involved in operations where this data was flowing in, and I have seen the IMINT people working day night without packing up, and it is humongous task. So if this is the area where the industry can certainly help in processing the data. And once we have processed data, this is an ongoing process, and we are collating, archiving all this information, and that needs to be distributed and given in the format that is talking to our weapon systems, or for our pilots to study, like the Maxar covered the fly-through part. It comes in very handy. If we have that kind of things, our mission reliability in execution will increase manyfold. And I am sure all the speakers here will do their bit in giving us insight into these infrastructures. Now I throw open to first Colonel Jairam, please. Thank you.
Good afternoon, ladies and gentlemen. I take this opportunity to put across my views on geospatial technology, infrastructure development from the perspective of defense forces. Respected chair and my fellow panelists will throw some light on the infrastructure, on the network and other aspects. I'll focus more on what is geospatial technology infrastructure development mean for the armed forces. It'll involve all the domains that you have been hearing here in the first few sessions. It's not going to be restricted to just the space, because geospatial technology is all pervasive. So when we start with the military operations, as a military man, geospatial technology actually deals with three important elements as per me. The first aspect is understanding the battle space clearly and unequivocally is the actual outcome towards the successful operations. The second element is to track, locate, and detect the deployments of the adversary in the same battle space. Is the second important element. And the third important element as per me is to give the positional accuracy of these deployments. So how do I get, as a military man, these three elements through geospatial technology. So if I say I link geospatial technology directly with the outcome of operations, I will not be wrong. So the evolution of geospatial technology has to be seen as a synonymous with development of the operational doctrine. But most of the time, geospatial technology is considered as a mere technology, and connecting with the operations takes a back seat. So with this as a background, I want to show you geospatial technology also, I see it as three important domains. You see the mapping, geospatial intelligence, and the GIS framework, and how in services we do. Mapping and surveying is done by two very, very professional outfits, the Military Survey and Department of Hydrography. Now, Military Survey takes care of the operational requirements of Army and Air Force, and Department of Hydrography takes care of the naval requirements. However, when we deal the tri-service level operations, the targeting accuracies that are required, are they collaborating? Yes, they are. But what kind of framework that we need to give so that this becomes very seamless? So we need to understand geospatial technology growth as a comprehensive one domain rather than silos, the verticals in coming up as silos. The second important domain is remote sensing and photogrammetry, where the entire space domain comes in, where our entire technologies, niche technologies come in. Now, this is handled very effectively by Defense Space Agency and Defense Intelligence Agency. That's how you will not find services talking in different languages and different formats, because it is handled at tri-service level. Now, the third thing, important thing, is GIS framework, where we have large number of GISs available. Whenever we get an equipment, it comes with a GIS, it comes with a proprietary format. The data standards are different. The database requirements are different. Unless we spell out a policy at the tri-service level, at the GISQR level, every industry will try to give a better product in his own way, with his own standards. And then when at tri-service level we want to match it, we will find problems. So these are some of the problems that we see when we further club up all these three domains into various problems that I see. You see from left to right in the center, GIS, formats, and applications I have written. So whenever we are procuring an equipment, whether it comes from a government to government basis, from a foreign OEM, or from a defense industry, within indigenous industry, or from private industry, they all have their own formats and standards. Unless we ask them, they will give you what their standard, the best is. Similarly, the database standards are different. The features, attributes, and relationships, the way we see, the Army, Navy, and Air Force see it, it has to be one. The spatial data model that we need to give out will have to be one. So I'm trying to provide the industry with some of the issues they should bear in mind when they're developing products. Similarly, the coordinate systems, Air Force may see it in spherical formats, Army will see in rectangular, Navy sees both, where the datum, projection, and elevation, there are standardization issues. We need to have one. So these are some of the problems that we face. So there are some issues that I realized where the monitoring centrally will have to take place. So that is at the sourcing level, and testing and certification has to be common. We need to understand that a product that is certified by one agency will have to be agreeable to everybody in the services. Similarly, the storage, we need to have common storage formats, and the standards and protocols have to be, policies have to be issued centrally. So some of the aspects that I saw, if you see now, these are the areas of geospatial technology infrastructure development. So when in India, when you say, or across the globe, geospatial technology growth is taking place, unless it takes place in a comprehensively as one framework, it is going to have only different verticals, and joining up at the top is going to be a problem. So these are the various areas where we at the government level, at the top, we are trying to formulate certain policies. Maybe in due course, we will try and plug them all. And some of the end states that I have mentioned, just for an academic interest. So what I tried to convey in the last 10 minutes or so is the geospatial technology infrastructure development is taking place at a very fast pace. We have large number of professional organizations that are existing, but for services to be able to use them, we need to have policy at the top, and these agencies have to interoperate with each other and integrate the systems so that at the tri-service level, the targeting accuracies can be achieved. Thank you.
Good afternoon, ladies and gentlemen. And I'm Commodore Arun Golaya. I'm also in charge of the Technology Development Acceleration Cell of the Indian Navy. Even as he puts up the presentation, to begin with, I would like to thank Satyam because he gives me a topic. Wing Commander Satyam Kushwaha gives me a topic which needs at least 5 hours, and he gives me precisely 5 minutes to cover it. We are from the same squadron, and we were posted together at NSCS, and I think he gets revenge for whatever I did to him by putting me in such situations. Having said that, this thing is also right that I always try and make everything too mathematical. And he accuses me that whenever this topic starts, you go into mathematics. So first of all, I promise I will try and not be mathematical. And I will just show you lots of pictures. 5 minutes, I cannot do anything more. Having said that, let's start with the puzzle. If you started from this auditorium and traveled successively, and I know most of you are experts, so you would be familiar with the answer, but if you started successively, went 100 kilometers north, east, south, and west, would you reach back where you started from? And no, it is not a trick question. And the question which follows on is the sum of the angles in a triangle, is it 180? And if you say yes, my question would be, is it always 180? Now, these are important questions. Let's take an extreme example. Answer to both of them is not what you expect it to be. Of course, as I said, let's take an extreme example. So if you started from the South Pole and you went north, turned 90 degrees, went east, turned south, you would reach back the South Pole without doing the fourth leg. So in an exaggerated view, a person moving 100 kilometers north, east, south, west will not reach the starting point. The sum of the angles in a triangle is 180 if it is a plane triangle. That means on a flat surface, not a spherical triangle which is on the surface of the earth. And I'm continuing from what Colonel Jairam mentioned, where he just kept, and I saw a few people at least giving the expression, what's he talking about? So today, and we didn't plan it, but I think we'll continue, and I will just try and show you what are the kind of errors you can have if you don't take into account what he said. Most naval, of course, officers and Air Force officers, of course, would be very well familiar with it. Army officers, and I'm not being this thing, but not so much. The difference between a rump line and a great circle, orthodrome and a loxodrome. Industry, surprisingly, quite a few people, I am actually surprised because, they do not take into account. And again, I have a witness here. Me and Satyam, we went across in one geospatial seminar like this. There were 8 industries, and we gave them the same problem statement, a basic direct and inverse geodesic problem, where you give 2 points and you ask them what's the range and bearing between them. And of course, it was staged because it's cos of Latin sec of, okay, I promise no maths. But we staged it so as to get the wrong answer. And the difference, all 8 of them gave different answers, and each of them claimed that my answer is correct. How much was the difference? Hundreds of meters? Kilometers? Hundreds of kilometers? It depends on the scale. We'll see this. The point which I'm trying to make is that if you're talking about a particular so many degrees by so many degrees grid, on the equator, at the tropic, or at the pole, the thing changes entirely. That is, of course, because the Earth is not flat. It is a sphere, not even a sphere. It is best approximated as an oblate spheroid, though it is an irregular shape and it is not even an actual oblate spheroid. So this causes problems. And after this, I have only pictures, and I will only be showing you pictures. And I've given citations wherever it's there. Otherwise, the copyright remains with the people. I've just taken screenshots from the net. So first question you'll ask is that this is childish stuff, and how does this childish stuff affect us? Okay, so this is, again, most of you would be knowing this. This is the Korean missiles, which was published by a reputed magazine. And you can see that the range of the missile is the same, and it just about reaches Alaska, if you're talking about the US. If you are in India, you are in trouble if they decide. This is the same missile, another reputed website, and you can see here it covers almost the whole of the US. The range is the same. A third website, again as reputed, and a fourth one. and you can see how much the difference is. So depending on which website you follow or which magazine you're following, in India you'd be safe in Kerala in the first case and probably not in the second case. So one is, of course, what's a few thousand kilometers between friends. But if you want to be accurate, the first one got the maximum amount of flack because on the internet, everybody said, all the purists said that how can a reputed magazine make such a mistake? So they published an apology. They hired a team of geospatial experts and they gave the corrected picture, which again, I wouldn't say is wrong, but is at variance with the other pictures which we've already seen. So it's no such thing as right or wrong. When it comes to that, you all have to agree to be equally right or equally wrong, because when you're converting from 3D to 2D, there would be some distortion. Shape, area, distance, bearing, and it makes a difference. I've just drawn a line here. It is showing you the same line if you're using WebMarketer, which Google uses. If you were using a local this is I've taken from the history website, this one. The state plane, which is a local projection, and the UTM. So the length of this would be 764 kilometers if you were using UTM, and it would be 1092 if you're using Google. So if you had a missile with 1,000 kilometers range, depending on what you're using, you could say, yes, it's within my range or it's not within my range. The difference is phenomenal, 764 and 1092. And that's why I've not made any presentation on my own. I'm just giving you screenshots from all reputed sources. Next, something as basic as how do you define a latitude? So when somebody says latitude and longitude and you say what latitude, he says, wo jo hota hai na, latitude, longitude. So are you talking about geodetic, geocentric, orthalic, parametric? And they're all different. And how different are they? We'll see. Normally, it says that when the terms latitude and longitude are used without qualification, they're normally assumed to mean geodetic. The GPS, for example, or most GNSS use geodetic. There are people who say that they're using WGS84 and they're using geodetic. And they also say that when you ask them that how are they doing the calculation between this thing, they say they're using the Haversine formula. If you're using the Haversine formula, you're assuming the Earth is a sphere. You can either use WGS84 or you can use the Haversine formula. I do not know how you can use both because by definition, one has only R, which is the radius of the Earth. The other has R1 and R2 based on which you calculate the flattening. And there are a number of firms who say that we are using WGS84. Are you using WGS84? Tick mark, yes. What formula are you using? Haversine formula, tick mark, yes. So this is a difference. This is not showing you this thing. It is showing you the difference from geodetic depending on the latitude. So in our latitude, the difference, as you can see in kilometers, is giving you there. So what will be the correction if you're using the geocentric, or if you claim you're using the geodetic but you continue using the Haversine formula, the difference would be of the order of 8 kilometers or 7 kilometers when compared to the geodetic. That difference is huge. I will not go into datums. Datums, I think more or less people are familiar with it. As I said, the Earth is an irregular shape. So you have a thing which tries and approximates a pretty good fit overall, but it may not locally be a good fit. You may locally have a better fit. I will not go into the details, but you can have as many positions in latitude, longitude terms or a place as you have datums. So that is the capital dome. It has been shown in different datums. Here it says Indian datum. I'm not sure what they mean by that, but I assume they mean the Everest spheroid. And that is about 800 meters off. But that would vary from place to place. It is not that. So even if people tell you that in a chart you shift it, or in a map, you shifted these many minutes southwards and these many minutes eastwards, that is an approximation for the entire chart. It is not. It is something because it's an irregular shape. It varies from place to place. Instruments which tell you that they will convert, it's based mostly on a lookup table. That means for a particular area, they would tell you that this much area, apply this much of correction, which means it may be good enough for visualization. It will not be good enough for navigation, and it will most certainly not be good enough for targeting. So I think that's the problem you were trying to highlight. I'm supporting you. So if you change the datum and resurvey, will the map shift? Yes. So this is a map. This is from the Mariner's Handbook. If you see the map which used to be there earlier is the red line. And when you resurveyed it in WGS84, the whole map just shifted. So if you had the map in the older datum and you're using the GPS, which uses WGS84, and you were plotting the fix on that, you would be on land when you thought you were quite safe and at sea, or totally at sea. Okay, so how much is the difference? The largest difference between satellite navigation derived and charted position reported so far, again, the quote is from the Mariner's Handbook, I have quoted it verbatim, is 7 miles. That's 7 nautical miles, so roughly about 13 kilometers in the Pacific Ocean, but even larger undiscovered differences may exist. So the first thing, there was 8 kilometers. The second thing, there was 7 kilometers. And of course, the first one was thousands of kilometers. That is separate. That was due to the projection. But as I said, what's a few thousand kilometers between friends? 3 map projections, the LCC, the Mercator, and the unprojected lat long, or what normally you say, the plate curry, or however you pronounce it. So if you see the map of the US in 3 different projections, that is the kind of a difference you will get. And then there are people who do insist that the projection doesn't really make a difference. You can actually convert on the fly. You can, but anytime you convert, there will always be some limitations, some errors. And it depends on what's, as I said, some people do it just on an area. It doesn't work. Not for targeting, at least. The next thing which I've heard people say is that, at that scale, it might make a difference. At a smaller scale, it doesn't make that much of a difference. This is the Earth in 2 global projections. One is Mercator, the second one is sinusoidal, and the same structure, if you just measure the length, in one case it is 492 meters, and the second one it is 510 meters. That means there's a difference of 18 meters in 500 meters, which is why if you try and put satellite imagery on a map or a chart, depending on which projection they're both in, most satellite imagery by default, now whether you are some of the industry also made a presentation. Most of it natively would be in space oblique Mercator, and it would be converted into UTM. If your chart or map is not in that, if you try and put it on top of it, it is not supposed to match. You can, of course, convert it, and you can do that, but by default, they're not even supposed to match. So if it matches, then you're in trouble. Rumline Great Circle we spoke about. I will not go into details, but if you've just flown even from Delhi to the US, you'll realize that you're supposed to be, if you draw a straight line on a map, you'll assume that you're going over Africa, but actually you go quite close to Greenland. That is because if you see the second picture, it becomes clear, because if the globe is like this, your map opens it out if you're in Mercator, but you don't go like that, you would be going like this actually. So the gentleman who invented the term loxodrome wrote 3 books about it, and thereafter, since he could not convince people, he decided for this reason to polish up some of the things I have written and set about studying philosophy and abandoned mathematics, in the study of which I have irretrievably lost my health. I am on the verge of following him. Thank you very much. I wish I had more time. And thank you, Satyam. And next time you do this, I'll get back.
What I'm going to talk about here in terms of geospatial infrastructure is how do we actually do sensor fusion onboard satellites, and how to actually get comprehensive information from there. So what is this all about? The satellite imaging ecosystem, you can clearly see, is actually about 3 levels. One is, first of all, what are the satellite systems that are there, and this would be actually the various entities that work on manufacturing systems for satellites and launching them. Then there are a bunch of companies that work on gathering the data from hardware, which is the sensors, and to capture a specific area of interest. And finally, the data has to be analyzed to develop a positive economic impact across industry. What is happening today, right? So today, for example, you actually have optical data, and I think we had significant talks about hyperspectral data and how that's emerging and how we need to be using this much better in the future and so on. And so you actually get like a lot of color information, which allows you to use that color as a context to enable feature recognition or feature identification. The problem with that is you, on a clear day, you can actually get this information because you have the sun's illumination on top of it. But when you have clouds, you have a significant cloud cover, you get like only partial image or maybe an obscured image. When it is night, even if you have no clouds and it's a clear sky, you don't really have illumination, and therefore you don't get an image. And of course, if it's cloudy at night, they have no chance. So fundamentally, no matter how resolved your spectrum is in terms of the visible spectrum, within the visible spectrum for hyperspectral imaging, you're actually going to get data only about approximately 25% of the time or even less. So what do we do then? So this is the infrastructure that I'm wanting to talk about. On the other hand, you can also actually rely on radar data. So radar data, on the other hand, is actually grayscale imagery, which means that it makes it difficult for us to identify features because you don't have the color context. On the other hand, when compared to the optical data, we have, whether it is day or night or whether it is clear sky or cloudy, you actually get this data because radar sensors can actually cut through these things and look at what exactly you have. Today, we have to decide between whether you want to have optical data or you want to have radar data. That's essentially where we are coming from. So how does fusion of these two data help is what we would like to be talking about. So let's actually look at a couple of examples. The first one is, for example, like the marine monitoring. The first image here is actually showing a couple of ships, but they are covered with cloud, and you can identify the ship have attributes, but the image, if the image were clear, right? So you and maybe specific locations on the ship, what you want to actually look at may be covered by the cloud. On the other hand, if you have a SAR image, you have difficulty in identifying the details of the image. So what we essentially present on the right-hand side is a fused and analyzed image where the analysis, of course, actually uses deep learning, where we have a significant amount of learning to be done on these typical images. And over time, you can actually do feature recognition on the fused image. So that's analysis that we're talking about. Let's actually also look at one more example, which is quite interesting, which is a forest fire monitoring situation. Now, in these situations, you don't really have to have the clouds in the sky, but the smoke that is billowing from these forest fires itself can obscure where the fire actually is. So if you now look at the left-hand side image, where you have fire over a significant area, but you also have some area that's obscured by the smoke that's billowing from the fire. The second image, on the other hand, actually shows the SAR image, which shows that you might have a fire everywhere in that area as well as in other places. So what you then do is to actually do a sensor fusion and analyze this in order to be able to tell exactly where the fire is, because that's going to be very, very important for us to be able to deduce. So what can actually artificial intelligence do here in order to boost capability? And that's where we were talking about not only the fusion, but also the analysis in order to be able to extract data. So the potential of data fusion is as follows. If you have, for example, if you take this forestry, right, and if you want to do a detection and classification, the optical image the classification based on optical alone is sometimes about 75.9% accurate, and SAR obviously is quite less, which is about 69.2 accurate. But the moment you actually do a sensor fusion, your accuracy improves to greater than about 83%. And the similar numbers for let's say monitoring land use and cover, you can actually bump it up to about 94% or more. So this is where actually 1 + 1 is actually greater than 2. The synthesis of those two data gives you more information than what would each of them give, right? So things like, for example, cloud cover removal itself has been like about a $300 million industry for real-time flood monitoring. So like a SAR interferometry, I think that was being talked about, you get like 1 millimeter accuracy of detecting changes, and then colored SAR data. So how do you actually now put artificial coloring on SAR data to make sense out of it? That actually gives you about 10x more data. So at IIT Madras, we have I'm from IIT Madras, Professor of Aerospace Engineering. So we have Galaxy incubated at IIT Madras and working with our center, where we are developing this kind of a sensor fusion approach to this, where we are having satellites with a sensor called Drishti sensor, and microsatellites with sensor capabilities of both SAR and optical imaging, coupled with edge computing. So that's the third part that I want to bring about here, which is the edge computing part. Where you have the synchronized sensor fused data set obtained on the edge. So multiple words are actually quite important here. So why would you want to have both SAR and the optical data on the same platform, which is the same satellite, is to register them together pixel for pixel, as well as synchronize them in time to obtain the same image at the same time. And this particular aspect is also done by a processor on board the satellite itself. So equipped with edge computers, then we actually make what's called as smart satellites. Specifically, we can also carve out that particular region of the field of view that we are taking images of and beam only the analyzed fused data back, and so that the downlink data rates that are required will be far less, and the amount of storage that you have on the ground will be far less if you do this kind of edge computing. And we suppose that a constellation of about 15 such satellites orbiting around the Earth can cover with reasonable revisit times for doing this kind of sensor fusion on the edge. Thank you very much.
May I ask you, Suyash, you're developing this coincident platform where optical and SAR is there. What are the challenges to data fusion that you are facing, and what's your approach to solving them?
First of all, sir, thank you so much for the opportunity to be here and talk to the users. I think data fusion, as Prof has walked us through, has its own unique advantages, but also there are some challenges. There are some challenges on the level of hardware. There's some challenges on the level of software as well. So if I talk about the hardware challenges, like SAR has to be off looking and can't be, at Nadir. However, optical is generally at Nadir. Of course, people have done it off Nadir as well, but the look angle is, very difficult to be, set up in that way. So that is the hardware challenge. And when it comes to software, the way you need to do digital signal processing over radars, but optical is more optical signal processing. So the way you bring in those two algorithms together is another level of challenge. So I think that those are the two challenges that we have been cracking at our place, and eventually we'll put that on a satellite. Even before that, we are putting this on an aircraft to do the sensing. So I think we are a little agnostic of the platform, be it airplane or satellite, but the sensor is pretty much taking its shape.
Thank you. Colonel Jairam, I understand that you have been associated with creating a kind of a Defense Geospatial Agency framework, which would bring infrastructural integration at the armed forces level. Could you throw some light on it as to what approaches are being applied and by when are we likely to see it?
What we have seen is, when I said the battle space, we understood it's not just the airspace or the terrain or the maritime expanse. It has moved to outer space and also the cyberspace and many other electromagnetic spectrum, the environment with weather warfare coming in. So what we started seeing is, when we see geospatial technology as only just a GIS or some tools that are coming in, and thereafter you're connecting it to an operational system would not be enough. We wanted to do something big and bring the tri-services onto one particular platform. So we did extensive discussions with the services, and we wanted to bring an agency which actually acts as a supporting agency rather than dictating agency. So whatever operational doctrines that are there already, so we need to have something that supports, augments their operational effectiveness, and then provide whether it is equipment, technology as policies. That's how this kind of an agency that we are planning at the defense level. It may come up in 6 months to 1 year's time.
Thank you. Commodore Gulaya, we have done a lot of journey together as far as the standardization of certain aspects of, say, geospatial processes were concerned at a certain stage. And we did realize that probably there were legacy thoughts that were preventing people to move forward. But the way we are seeing today, technology moving in the space segment coming in a very, very strong way, and also a lot of modernization happening in the surveying techniques. Um, uh, how do you see this roadmap towards standardization? How important it is today, and how should we approach keeping the sensitivities of each service as well as the requirements of common targeting and common warfighting requirements together?
Okay, I've got a slightly different take on this, and this is my personal view, not the official view. I personally feel it is not really necessary, or it may actually not be required to go for commonality or standardization to the extent that which we are wanting to. Let me explain that to you. When we were growing up, in the 70s or the early 80s, you had only two cars. You had the Ambassador and the Premier Padmini. That means there was a phenomenal amount of standardization. But were we happy? So even now, if you take any ship, any merchant ship, forget about a warship, you would be having at least 8 to 10 different kinds of GIS system, which would be there. You have the EGDIS for navigation. You'll have some kind of a CMS. You'll be having, various things are there. And requirements. So the requirements which are there for the Air Force for your, the ground-based center would be very different from what is required, say, in a helicopter or what is required in a fighter plane. So you cannot have one standard this thing. What is more important, and I'll just take 1 minute more. When I was teaching sub-lieutenants a long time back, this particular topic and geodesy, what I used to always tell them is that more than anything, the understanding has to be common. If somebody asks me, what's my height is 6'1.5". My height is also 187. Both the statements are correct. The problem is if I say my height is 187 and you take it as 1 foot 87 inches. It is the understanding, or even if everybody follows, the Air Force, for example, may like to prefer charts on a particular projection because they have certain requirements. The Navy may like to or would like to use the Mercator due to certain requirements. It is important that instead of trying to aim for commonality or standardization, you have an understanding of what the errors involved can be, rather than try and standardize. Now, as far as the industry goes, again, the requirements of each service, the presentation, in fact, what we've been seeing presentations this morning, if you're talking about 30 centimeters resolution, now the swath of the satellite would be inversely proportional to the resolution. If you have very high resolution, normally you would be having a lesser swath. So if you give me 30 centimeters resolution or even 20 centimeters resolution and it's 20 kilometers by 20 kilometers, it may be very useful for the Army, it may be very useful for the Air Force. The Navy, it may have very little utility, because if I knew where a ship is with an accuracy of 20 kilometers by 20 kilometers, I don't need to know where the ship is. I don't need satellite imagery for that. I would need to cover thousands of kilometers, and even if you give me 20 meters accuracy, resolution, that's good enough. So since the requirements are different, trying to standardize, as per me, it's open to debate. I think is not only wrong, I think it's dangerous.
I think I'll second that, because it is basically the requirement. Like he is talking about fixing position. Finally, whether we fix position of a target, anything, requirements are different. All three services operate differently, and it should be left to the services in which format they want. And there cannot be any commonality on that. Thank you.
Thank you, sir. Colonel Arun, sir. We saw Ukraine being covered very extensively by Maxar, and very, very cutting edge imagery was available, which could give a lot of detail of what's happening on the battle space. Now, a very important aspect also comes in real time or near real time processing and making it available to the people on ground. May know from Maxa perspective that how things are moving in terms of, say, directly connecting at the tactical level, and how technology is progressing at your ends.
So Satyam, it's not just about the timeliness. So it's a no-brainer that data needs to reach the user in time, right? That's it's a no-brainer for the services, right? And transcending all the phases of operations. There are multiple ways that data can be reached to the user, depending on the usage, on the use case. We have like
if you speak of the satellite domain, there are a whole lot of access systems that are there where you have your own ground stations directly tasking and downloading from the satellites, which responds and you get your data in minutes, not even longer times. And I think in the previous session we had Aaron covering some of the capabilities that our company brings in. It's not just about the timeliness, there is also the relevance of accuracy, availability on demand, the ability to, for it to be precise, as well as be able to use that data. Like the rest of the panelists also brought out, that data needs to be usable and in the format that the service requires, right? So those are, additional aspects of making data available. It's just not about whatever you capture, you feed it to the end user. It needs to be consumable by him. So there's a whole process involved where data images have got to be kind of processed, they've got to be correlated for accuracy, and then only it becomes usable. So it's not just about tasking a sensor and getting an image. It needs to be accurate, it needs to be precise, it needs to be consumable. So all those aspects also are pertinent.
Thank you, sir. May we have any questions from the audience? We have time for one or two questions, if any. Yeah, please. Can I request you to please wait? You'll get the mic.
Sir, my question is, you talked the importance of the synchronization and the co-location of the sensors in a platform, and that requires and helps in the multi-sensor fusions. So what is the level of synchronization that is required between the different sensors like UIR with the SAR images? And what is the impacts if you don't get that kind of accuracy in the synchronizations? And what are the technologies like whether it is possible to microsecond level of synchronization or nanosecond level of synchronizations? What is the present technology available, and to what extent it is presently available in the market also? Thank you.
I'll probably answer your question. So I think you asked two questions. What if the synchronization doesn't happen in the right way? And second is, what is the level of time synchronization that we need to achieve? So I think today, if you take two imagery from two different satellite companies, you'll have one multispectral imagery, another SAR imagery. It's difficult to fuse them together for three different reasons. Spatial resolution is not same, temporal resolution is not same, spectral resolution is not same. So I think those same problems can come through when you co-locate the same sensors at the same platform. And the way we are overcoming it is of course different level of synchronization. So time synchronization, I think it goes to the something very similar to how you do it in self-driving cars. Where you have lidars, you have radars, you have cameras syncing up together, and then the different level of fusions are also there, like pixel level, decision level, and the decision level, pixel level, and feature level as well. So yeah, I think today probably there's no sensor that is available that will co-locate at some clock. I mean, at least we don't know of right now. And these two sensors, there are different other things that is coming up, like where SAR is multiple bands of SAR is coming together, multiple resolutions of optical coming together, but we have not seen something that is which is a multispectral and radar coming together. So I can't comment on the time synchronous well apart. Thanks.
I apologize, I missed out Gamal Sai's presentation, sir. May I please. Otherwise, we can. With your permission, sir. So we may move forward. May I please request all members to please come forward. Suyash was already covered. Sir, go. Please come forward.